All right, let's get right into it. We're all getting pretty used to AI assistants that can do some seriously incredible things, right? They can plan your vacation, they can write code, they can settle a debate about who discovered gravity. They really do feel like these super intelligent brains in a box. But what if their biggest weakness, their most critical flaw, isn't in their brain at all?
Today, we're basically going to be detectives. We're looking into a threat that isn't some crazy, sophisticated cyber attack. Nope. It's something way more common, and maybe, just maybe, a lot more dangerous. We're asking, what happens when an AI's most basic tools just break? So, to understand the problem, first, we've got to pop the hood and take a look inside the AI's digital toolbox. We need to see how these things, these agents, actually get work done in the real world.
It's actually a pretty simple loop when you break it down. The agent thinks, okay, I need to solve this part of the problem. Then it reaches into its toolbox and grabs the right tool for that specific job. It uses the tool, gets a result back, and then decides what to do next. You see, this simple act of delegating tasks is what makes these AIs so incredibly powerful.
And these tools are often super basic things you'd expect. You've got a calculator tool for doing math, a search tool for looking stuff up online, a Wikipedia tool for facts, or even a simple date time tool just to check the date. These little programs are the absolute backbone of what an AI agent can do. They're simple, they're reliable, or are they?
And that right there leads us to the central question of this whole investigation. What happens when these perfectly good, simple tools go bad?
And again, we're not talking about some kind of malicious hack. What if they just fail? You know, the way any piece of software can just glitch out or crash? Well, that's the exact question a fascinating research paper called ChaosLLM decided to find out.
The researchers zeroed in on 4 very common, very normal ways a tool can fail. First, it could be unreachable, like a dead web page. It could have a slow response, taking forever to give an answer. It could hang, which means it just ghosts the AI and never responds at all. Or, and this is the really sneaky one, it could give an incorrect response that looks perfectly fine on the surface.
So, how in the world do you actually test for these kinds of failures in a controlled way? Well, the researchers basically came up with the idea of a fire drill for AI. They built this framework they call ChaosLLM. If you've ever heard of chaos engineering, it's pretty much that, but for AI. It's a system designed to intentionally break things. It injects these faults on purpose. It'll make the calculator tool freeze up, or it'll force the search tool to return bad data, all to see how the AI agent reacts when things go sideways. It's a stress test for the AI's toolbox.
So to run these fire drills, they took 3 different AI models, including some big names like GPT-4 and GPT-4 Mini. And they gave them a bunch of simple, everyday tasks. Stuff like converting currency, splitting a restaurant bill, or answering a basic trivia question. Nothing too crazy. And each task just needed 1 or 2 of those basic tools we saw earlier. All right, so the stage is set. They ran 225 of these experiments. How did these super powerful, cutting-edge AI agents actually handle the chaos? Let's take a look at the results.
The results were, well, pretty surprising. While one of the models did a bit better than the others, the real story here is that every single model struggled, a lot. Even a powerhouse like GPT-4 failed on more than 1/3 of the tasks the moment its tools started getting flaky.
And when they failed, what was the biggest reason? This number is pretty wild. A whopping 52%, over half of all the task failures were timeouts, and they were caused by just one type of fault, the hang, where a tool just never got back to the AI. The agents literally just sat there, waiting and waiting until the clock ran out. They just froze.
But digging a little deeper, some failures weren't really a big deal. For instance, a tool that was just a bit slow had almost no effect. The AI agents were perfectly happy to wait. And get this, if a tool sent back complete gibberish, just a jumble of random letters, the agents were actually smart enough to go, whoa, that's not right, and just ignore it. But that cleverness was hiding a much bigger vulnerability.
Because it turns out the most dangerous failures weren't the obvious ones at all. The real Achilles heel, the one thing that fooled every single AI they tested, was something far more subtle.
The paper puts it perfectly. They call this the subtle delta corruption, and they flat out label it the Achilles heel of every model. So, what in the world is this critical flaw?
Okay, here's the difference, and it's so important. When a tool returned data that was obviously wrong, like that random junk text, the agent recognized it as an error and ignored it. That's a success, but when the tool returned an answer that was just subtly wrong, say a number that was off by 10% but still looked totally plausible, the agent trusted it completely. It took that bad data and confidently presented it as the correct answer. That is what we call a silent failure.
And how big of a problem was this? Well, these subtle, plausible, but wrong errors were responsible for 42% of all the hallucinations in the entire experiment. That means 42% of the time, the AI gave a confidently wrong answer. It was because it blindly trusted a faulty tool.
So, what are the big takeaways from all this? First, tools that just hang and don't respond are a huge problem. They can completely freeze an AI agent. Second, and this is the big one, these subtle errors are incredibly dangerous because they cause silent failures. The AI doesn't even know it's wrong. And finally, the research really suggests that fixing this isn't about just building a smarter AI. It's about building smarter systems around the AI, with much better checks and validation for the tools themselves.
And this all leads us to the final, really crucial question. Look, this experiment used simple tools for simple tasks, right? But as we start to trust AI agents with bigger, more mission-critical jobs, the tools get way more complex, and the consequences of a silent failure become much, much higher. So the real challenge ahead isn't just about making the AI smarter, it's about making its entire ecosystem more dependable. Because at the end of the day, how can we ever really trust the AI if we can't trust its tools?